These are two boards with both ground low voltage and high voltage on them, and this is showing that the separation is above 4 millimeters under conformal code. Now going to the high current path through all the bolted connections, just showing that this is a patch bolt, and the other bolt we use on our segment is also a patch bolt, as you can see in this freeze frame. And we're using no gloves in this video because it is under 60 volts, under high voltage. And here's another patch bolt. And then in the isolation relays, we have another patch bolt here. And then on the fuse, we have a nylock nut. Here we're just showing that the top of the stacks is electrically insulated and fire resistant through Mk.11, and then all of the walls of the accumulator are also electrically insulated and fire resistant by Mk.11. Here we're just showing that our voltage taps are being fused within 150 millimeters from the source. And then again, just showing that all of our branch circuits within our server section are being fused from 150 millimeters of the source of both the positive and the negative isolation relays. This shows our fuse, which is terminals are capped on tapes, and this shows our isolation relays, which terminals are also capped on taped. And this is just showing that our receptacles of our tractor system connector are directly following an isolation relay.
These ones, you don't need any tools to remove. These have notches grab on the gloves. Just slide up. Showing that it's only continuous and conductive where we want it to be, and not on the housing of the maintenance plug. And just showing again, it's not continuous on the housing, but only on the two contacts.
The one on the bottom. Yeah, the one.
Okay. So take it off. We already have these off, but these will be connected with some bolts and nylocks. So that's all positively locked. Take off the lid. Slide it off. So the way these goes on, these are attached to a polycard sheet. It's laid on top. These ones are zip tied in, so it can't be moved around. Besides a little bit of play that's intended. It cannot connect to any of the other ones because it's obstructed by the polycarb, and it's also meant to slot into these parts of the walls. Here. Let's try it happen again. This one goes on the other side, follows the same premise as this one. It's the other one right here. So for these maintenance plugs that go across here, all of these are the same distance from each other. These ones are too far apart, so they cannot connect this way. The only way to connect is right here. And they're all the same interchangeable, so nothing to worry about that. Now for positive locking, these are all positively locked by way of the lid. So these ones are made to sit flush with this top here. They're not able to vertically translate because they're surrounded by the lid. So to demonstrate, if I hold this here, these are all sitting flush. They can't move vertically and they cannot rotate because they're obstructed by the two pins. So that 2 points of contact stops them from rotating. Can't translate anywhere across here. These two are also held secondarily by the lid, which the socket that's in the service section that we have, it obstructs it from moving too far up. So it's all designed with those tolerances in mind. So in this part here, these two pins are supposed to be guided into these sockets here. That's why they have a little bit of play in order to allow them to guide in if they're seated a little bit off. But you can see on the inside of there, there's a ceiling to how far these pins go up. And that's all made so that these things cannot push up on their own.
And just showing here that the lid is positively locked with nylock nuts. This is showing our high voltage indicator light working outside of the car, and it uses a buck converter that has an under voltage lockout at 60 volts. These are all the tractor system connectors we use in the car. I'm just trying to show all of the interlock connectors on the connectors, and also want to show the interlocks on the receptacle side. And the receptacle also inside of our accumulator. And this is our charging cable. I'm just trying to show the interlock on that connector, as well as a fuse that is 150 millimeters from the connector. And here is our other connector. And just trying to show another fuse, as there is an ampacity change in the wires, as well as the other interlocked on the other connector. So this is our charging box, which has our red banana plugs that are connected to HV plus and HV minus through a 15K resistor.